Hello everyone, welcome to ODIA IITian. In this video lecture, we will discuss optical mineralogy and numericals related to it, which are asking in IITjam and GET entrance frequently. So the first optical property is double refraction. When a ray of light passes through an anisotropic crystal, it breaks into two polarized rays vibrating in mutually perpendicular direction. Generally, double diffraction is the process to convert unpolarized light into polarized light. Polarized light are those which have single vibration direction. One ray obeys law of refraction, that is ordinary ray. Another ray does not obey law of refraction, that is extraordinary ray. When unpolarized light hit to a anisotropic mineral, it breaks into two polarized light. One is extraordinary ray, another is ordinary ray. The ordinary ray travels in same velocity in all directions through the crystal, which is isotropic in nature. North-south is the vibration direction of ordinary ray. Extraordinary ray, the velocity of this ray change with vibration with its path through crystal, and refractive index also change, which is anisotropic in nature. East to west is the vibration direction of extraordinary ray. Refractive index of E ray is maximum when velocity is minimum, which is parallel to c-axis direction. Next topic is optic axis. A direction in an isotropic mineral along which no double refraction takes place is known as optic axis. Mineral of tetragonal hexagonal system have one optic axis. Mineral belongs to orthogonal monoclinic triclinic system have two optic axes. Mineral which are crystallized in cubic crystal system are isotropic in nature, so that they have infinite number of optic axes. Another concept is refractive index in crystallography corresponds to length of crystallographic axis. It is the most important part. देखिए क्यूबिक सिस्टम में A इक्वल टू बी इक्वल टू सी, जब हम क्रिस्टलोग्राफी पढ़ेंगे तब हम यहाँ पे सिस्टम को अच्छे से पढ़ेंगे. अभी के लिए आप जान लीजिए A equal to B equal to C, here only one refractive index. Tetragonal system, A equal to B, which is one refractive index, is not equal to C, which is another one refractive index. So here two refractive index. Similarly, in hexagonal crystal system, A1 equal to A2 equal to A3, which have one refractive index. Another which is not equal to C is second refractive index. Orthorhombic system, A not equal to B and not equal to C, which are three refractive index. Refractive index, which is denoted as nu, equal to speed of light in vacuum divided by speed of light in a medium. It is unitless and dimensionless. The value of refractive index is greater than or equal to 1. When the refractive index increase, density also increase and velocity of light decrease. According to Snell's law, when a ray of light passes from rarer medium to denser medium, it moves away from the normal. So in this case, incident ray is making I angle with the normal, and refractive ray is making R angle with the normal. Here in this case, sin I by sin R is a constant which is nu. This is the important formula which you have to remember for solving numericals. Sin I by sin R equal to nu 2 by nu 1 equal to nu 2 with respect to nu 1 equal to velocity of rarer medium divided by velocity of denser medium equal to lambda 1 by lambda 2. Next, moving to the numerical. If a ray is traveling from denser medium to rarer medium and angle of incident is 30 degree, angle of refraction is 60 degree, and the velocity of light is 4 km per second each denser medium, then find the velocity of refraction ray in rarer medium. In this case, light is moving from denser medium to rarer medium with an incident angle 30 degree and refracting angle 60 degree. In this numerical, given is velocity of light is 4 km per second in denser medium. We can apply the above formula here. Sin I by sin R equal to V1 by V2. Sin I, that is incident ray, is 30 degree. Sin R, which is the 60 degree, एंड V1 इज द डेंसर मीडियम। डेंसर मीडियम में जितना दिया गया है वेलोसिटी 4 किलोमीटर पर सेकेंड, हमको निकालना है V2 यानी रेयरर मीडियम में वेलोसिटी ऑफ लाइट कितना है। सिमिलरली हम यहाँ पे V2 का अगर निकालेंगे then the answer is 6.584. Next, moving to birefringes. It is the difference between maximum refractive index and minimum refractive index of a mineral. E ray parallel to C axis is maximum refractive index. That is, another concept is retardation, the distance by which the slow ray lag behind the fast ray. When the slow ray has already emerged from an anisotropic crystal, the first ray has already traveled some distance, is known as retardation. The formula of retardation is birefringes into thickness. We know birefringes is the difference between maximum refractive index and minimum refractive index of a mineral. The unit of retardation is nanometer. Birefringes and retardation of isotropic crystals are always 0. Next, numerical are calculate retardation when refractive index of E ray is 2.5, O ray is 3, thickness of crystal is 50 micrometer. So in this case, birefringes equal to 3 minus 2.5 equal to 0.5 multiplied by the thickness of the crystal, which is 25 micrometer. If O ray is traveling with velocity 2 into 10 to the power 8 meter per second and E ray is traveling with velocity 2.5 into 10 to the power 8 meter per second through a crystal of thickness is 20 millimeter, find the retardation. Here in this question, velocity of O ray is 2 into 10 to the power 8 meter per second. Refractive index is C. We know C by B. That is 3 into 10 to the power 8 meter per second divided by 2 into 10 to the power 8 meter per second. That is 1.5. Similarly, refractive index of V ray, that is refractive index, that is the velocity of light in vacuum divided by velocity of light in medium, which is 1.2. Here birefringes, that is the difference of maximum refractive index minus minimum refractive index, that is 0.3. And similarly we multiply the thickness here given here 20 millimeter, so the answer is 6 millimeter. If you want the notes, then join our Telegram group ODIA IITian, link is given below. Thank you for watching this video lecture. If this lecture is informative to you, please like, share and subscribe. Thank you.